Hello friends, moving on to the next question. The color code of a resistance is given below. So this is a common question that everybody know, I hope so. Using BB Roy of Great Britain had a very good wife. So using the mnemonic you could solve this. I will also solve for you. Since yellow, violet, brown, gold, yellow and violet, yellow stands for 4, violet stands for 7, yellow, so 47 will be the initial part multiplied by its multiplier, which is brown, and gold, hence the tolerance is 5 percentage. Brown you could see it's 10. So 47 into 10. 47 into 10 is going to be 470 ohm and tolerance will be 5 percentage. The capacitance of a parallel plate capacitor with air as medium is 6 microfarad. With the introduction of dielectric medium, the capacitance becomes 30 microfarad. Hence, you can find the dielectric constant of the material, which is given by K equal to C by C naught, 30 by 6 micro and micro getting cancelled, so it's 5. So K equal to 5, and the same formula is also provided in NCERT. K equal to C by C naught, and using K equal to epsilon by epsilon naught. So epsilon is the question, the permittivity of the medium is question. K equal to epsilon by epsilon naught, so or epsilon naught K equal to epsilon. So epsilon naught is given and K is 5, multiplying you will get the answer. So moving on to the next question. A resistance wire is connected in the left gap of a meter bridge, balances a 10 ohm resistance in the right gap at the point which divides the bridge wire in the ratio 3:2. If the length of the resistance wire is 1.5 meter, then the length of 1 ohm of the resistance wire. So here there is a language trap. So whenever one thinks of resistance wire, everybody tries to connect it with the wire that is connected in the meter bridge, but they clearly differentiated it as bridge wire. Bridge wire is different, resistance wire is different. Usually we connect a resistor in the left and right gap of a meter bridge, but instead of a resistor in the left gap, there is a resistance wire in the left gap of a meter bridge, and a meter bridge balances a 10 ohm resistance in the right gap. It is given 10 ohm resistance in the right gap at a point which divides the bridge wire in the ratio 3:2. So it divides it in the ratio, it seems 3:2. Since ratio is provided, take it as 3x and 2x, or simply 3 by 2. So using the formula R equal to S into L1 by 100 minus L1, since the lengths are known, you could directly find R as unknown R, let it be unknown R, divided by 10 equal to 3x by 2x. It's 5, so the unknown resistance will have 15 ohm. The resistance of the resistance wire is 15 ohm. If the length of the resistance wire is 1.5 meter, the length of 1 ohm of the resistance wire. There is also a formula R equal to rho L by A, which we know. R equal to rho L by A, so R is directly proportional to L. For 1.5 meter, R is directly proportional to L, or R equal to KL. Say for 1.5 meter, the resistance is 15 ohm. 15 ohm for 1.5 meter, the resistance is 15 ohm. So K equal to 10. When the length of 1 ohm of the resistance wire is unknown, so the resistance of the 1 meter, or the length of the 1 ohm of the resistance wire. So resistance, if it is 1 ohm instead of 15 ohm, what will be its length? Again K into L dash. 1 K is already found to be 10 multiplied by L dash. So L dash equal to 1 upon 10, which is 10 power minus 1 meter. So next question, light with an average flux of 20 watt per centimeter square, average flux or intensity both are same words, falls on a non-reflecting surface. For reflecting surface you have to consider a multiplier of 2. You have to multiply a number 2 if the surface is reflecting, because it has to take in and it has to give out. So you will have to multiply the entire flux with a number 2. Since it's a non-reflecting surface, there is no worry about multiplying 2. For non-reflecting surface, it just transmits or it absorbs. So you need not multiply by 2. At normal incidence having surface area of 20 centimeter the square, the energy received by the surface during time span of 1 minute. So it is given that intensity equal to 20 watt per centimeter square. So careful with the units, to be careful with the units. So next, intensity is equal to energy per unit area per unit time. Energy per unit time is what we call it as power. Power will have a unit watt and area may be meter square or centimeter square. So energy is question, time is given to be 1 minute, area is given to be 20 centimeter square, and the flux is given to be 20 watt. So simplifying, you will be able to reach energy. So 20 watt per centimeter square into 20 centimeter square multiplied by 1 minute. Since the answer is given in joules or SI unit, just multiply it with 60 seconds. So 20 multiplied by 20 multiplied by 60 is 24 into 10 power 3 joules. So moving on to the next question. A 40 microfarad capacitor is connected to 200 volt 50 Hz AC supply. The RMS value of the current in the circuit. So RMS value of the current whenever a value of voltage is provided. For the previous question, the intensity formula for intensity is given in NCERT and there is a proof for this. And for the next question, XC equal to 1 by omega C, IM equal to VM by 1 by omega C, or IRMS equal to VRMS by 1 by omega C. IRMS equal to VRMS by 1 by omega C, which is VRMS into omega into C. VRMS is given to be for 200 volt. There are two kinds of value. One is the maximum value and the other one is the RMS value. Whether 200 volt is given is you may get confused that whether it is RMS value or maximum value. Whenever it is not mentioned that its maximum value or RMS value, simply consider it to be RMS value. So 200 volt multiplied by omega. Omega is not known. Instead, frequency is given. So omega equal to 2 pi nu. 2 pi nu into C is 40 micro. 10 power minus 6. Solving, you will be able to reach 2.5 ampere. The RMS value of the current in the circuit is nearly, since use of pi may take it to odd number, so nearly, approximately. Thank you for now.